2. Welcome to the solar system. Astronomers these days can do the most amazing things. If someone struck a match on the moon, they could spot the flare. From the tiniest throbs and wobbles of distant stars, they can infer the size and character and even potential habitability of planets much too remote to be seen. Planets so distant that it would take us half a million years in a spaceship to get there. With their radio telescopes, they can capture wisps of radiation so preposterously faint that the total amount of energy collected from outside the solar system by all of them together since collecting began in 1951 is less than the energy of a single snowflake striking the ground, in the words of Carl Sagan. In short, there isn't a great deal that goes on in the universe that astronomers can't find when they have a mind to, which is why it is all the more remarkable to reflect that until 1978 no one had ever noticed that Pluto has a moon. In the summer of that year, a young astronomer named James Christie at the Lowell Observatory in Flagstaff, Arizona, was making a routine examination of photographic images of Pluto when he saw that there was something there, something blurry and uncertain, but definitely other than Pluto. Consulting a colleague named Robert Harrington, he concluded that what he was looking at was a moon, and it wasn't just any moon. Relative to the planet, it was the biggest moon in the solar system. This was actually something of a blow to Pluto's status as a planet, which had never been terribly robust anyway, since previously the space occupied by the Moon and the space occupied by Pluto were thought to be one and the same. It meant that Pluto was much smaller than anyone had supposed, smaller even than Mercury. Indeed, 7 moons in the solar system, including our own, are larger. Now, a natural question is why it took so long for anyone to find a moon in our own solar system. The answer is that it is partly a matter of where astronomers point their instruments and partly a matter of what their instruments are designed to detect and partly it's just Pluto. Mostly, it's where they point their instruments. In the words of the astronomer Clark Chapman, most people think that astronomers get out at night in observatories and scan the skies. That's not true. Almost all the telescopes we have in the world are designed to peer at very tiny little pieces of the sky way off in the distance to see a quasar or hunt for black holes or look at a distant galaxy. The only real network of telescopes that scans the skies has been designed and built by the military. We have been spoiled by artists' renderings into imagining a clarity of resolution that doesn't exist in actual astronomy. Pluto in Christie's photograph is faint and fuzzy, a piece of cosmic lint, and its moon is not the romantically backlit, crisply delineated companion orb you would get in a National Geographic painting, but rather just a tiny and extremely indistinct hint of additional fuzziness. Such was the fuzziness, in fact, that it took 7 years for anyone to spot the moon again and thus independently confirm its existence. One nice touch about Christie's discovery was that it happened in Flagstaff, for it was there in 1930 that Pluto had been found in the first place. That seminal event in astronomy was largely to the credit of the astronomer Percival Lowell. Lowell, who came from one of the oldest and wealthiest Boston families, the one in the famous ditty about Boston being the home of the Bean and the God, where Lowell spoke only to Cabots, while Cabots spoke only to God. Endowed the famous observatory that bears his name, but is most indelibly remembered for his belief that Mars was covered with canals built by industrious Martians for purposes of conveying water from polar regions to the dry but productive lands nearer the equator. Lowell's other abiding conviction was that there existed somewhere out beyond Neptune an undiscovered ninth planet, dubbed Planet X. Lowell based this belief on irregularities detected in the orbits of Uranus and Neptune, and devoted the last years of his life to trying to find the gassy giant he was certain was out there. Unfortunately, he died suddenly in 1916, at least partly exhausted by his quest, and the search fell into abeyance while Lowell's heirs squabbled over his estate. However, in 1929, partly as a way of deflecting attention away from the Mars Canal saga, which by now had become a serious embarrassment, the Lowell Observatory directors decided to resume the search and to that end hired a young man from Kansas named Clyde Tombaugh. Tombaugh had no formal training as an astronomer, but he was diligent and he was astute, and after a year's patient searching he somehow spotted Pluto, a faint point of light in a glittery firmament. It was a miraculous find, and what made it all the more striking was that the observations on which Lowell had predicted the existence of planets beyond Neptune proved to be comprehensively erroneous. Tombaugh could see at once that the new planet was nothing like the massive gas ball Lowell had postulated, but any reservations he or anyone else had about the character of the new planet were soon swept aside in the delirium that attended almost any big news story in that easily excited age. This was the first American discovered planet, and no one was going to be distracted by the thought that it was really just a distant icy dot. It was named Pluto, at least partly because the first two letters made a monogram from Lowell's initials. Lowell was posthumously hailed everywhere as a genius of the first order, and Tombaugh was largely forgotten, except among planetary astronomers who tend to revere him. A few astronomers continue to think there may yet be a planet X out there, a real whopper, perhaps as much as 10 times the size of Jupiter, but so far out as to be invisible to us. It would receive so little sunlight that it would have almost none to reflect. The idea is that it wouldn't be a conventional planet like Jupiter or Saturn. It's much too far away for that. We're talking perhaps 4.5 trillion miles, but more like a sun that never quite made it. Most star systems in the cosmos are binary, double-starred, which makes our solitary sun a slight oddity. As for Pluto itself, nobody is quite sure how big it is, what it is made of, what kind of atmosphere it has, or even what it really is. A lot of astronomers believe it isn't a planet at all, but merely the largest object so far found in a zone of galactic debris known as the Kuiper Belt. The Quipper Belt was actually theorized by an astronomer named F. C. Leonard in 1930, but the name honors Gerard Kuiper, a Dutch native working in America who expanded the idea. The Kuiper Belt is the source of what are known as short-period comets, those that come past pretty regularly, of which the most famous is Halley's Comet. The more reclusive long-period comets among the recent visitors Hale-Bopp and Hyakutake come from the much more distant Oort cloud, about which more presently. It is certainly true that Pluto doesn't act much like the other planets. Not only is it runty and obscure, it is so variable in its motions that no one can tell you exactly where Pluto will be a century hence, whereas the other planets orbit on more or less the same plane. Pluto's orbital path is tipped, as it were, out of alignment at an angle of 17 degrees, like the brim of a hat tilted rakishly on someone's head. Its orbit is so irregular that for substantial periods on each of its lonely circuits around the Sun, it is closer to us than Neptune is. For most of the 1980s and 1990s, Neptune was in fact the solar system's most far-flung planet. Only on 11th of February 1999 did Pluto return to the outside lane, there to remain for the next 228 years. So if Pluto really is a planet, it is certainly an odd one. It is very tiny, just 1/4 of 1% as massive as Earth. If you set it down on top of the United States, it would cover not quite half the lower 48 states. This alone makes it extremely anomalous. It means that our planetary system consists of four rocky inner planets, four gassy outer giants, and a tiny solitary ice ball. Moreover, there is every reason to suppose that we may soon begin to find other, even larger icy spheres in the same portion of space. Then we will have problems. After Christie spotted Pluto's moon, astronomers began to regard that section of the cosmos more attentively, and as of early December 2002, had found over 600 additional trans-Neptunian objects, or Plutinus as they are alternatively called. One, dubbed Varuna, is nearly as big as Pluto's moon. Astronomers now think there may be billions of these objects. The difficulty is that many of them are awfully dark. Typically, they have an albedo, or reflectiveness, of just 4%, about the same as a lump of charcoal, and of course, these lumps of charcoal are over 6 billion kilometers away. And how far is that exactly? It's almost beyond imagining. Space, you see, is just enormous, just enormous. Let's imagine, for purposes of edification and entertainment, that we are about to go on a journey by rocket ship. We won't go terribly far, just to the edge of our own solar system, but we need to get a fix on how big a place space is and what a small part of it we occupy. Now, the bad news, I'm afraid, is that we won't be home for supper. Even at the speed of light, 300,000 kilometers per second, it would take 7 hours to get to Pluto. But of course, we can't travel at anything like that speed. We'll have to go at the speed of a spaceship, and these are rather more lumbering. The best speeds yet achieved by any human objects are those of the Voyager 1 and 2 spacecrafts, which are now flying away from us at about 56,000 kilometers an hour. The reason the Voyager craft were launched when they were in August and September 1977 was that Jupiter, Saturn, Uranus, and Neptune were aligned in a way that happens only once every 175 years. This enabled the two Voyagers to use the gravity assist technique, in which the craft were successively flung from one gassy giant to the next in a kind of cosmic version of crack the whip. Even so, it took them 9 years to reach Uranus and a dozen to cross the orbit of Pluto. The good news is that if we wait until January 2006, which is when NASA's New Horizons spacecraft is tentatively scheduled to depart for Pluto, we can take advantage of favorable Jovian positioning, plus some advances in technology, and get there in only a decade or so. Though getting home again will take rather longer, I'm afraid. At all events, it's going to be a long trip. Now, the first thing you are likely to realize is that space is extremely well named and rather dismayingly uneventful. Our solar system may be the liveliest thing for trillions of miles, but all the visible stuff in it, the sun, the planets and their moons, the billion or so tumbling rocks of the asteroid belt, comets, and other miscellaneous drifting detritus, feels less than a trillionth of the available space. You also quickly realize that none of the maps you have ever seen of the solar system was drawn remotely to scale. Most schoolroom charts show the planets coming one after the other at neighborly intervals. The outer giants actually cast shadows over each other in many illustrations, but this is a necessary deceit to get them all on the same piece of paper. Neptune in reality isn't just a little bit beyond Jupiter, it's way beyond Jupiter. 5 times further from Jupiter than Jupiter is from us, so far out that it receives only 3% as much sunlight as Jupiter. Such are the distances, in fact, that it isn't possible in any practical term to draw the solar system to scale. Even if you added lots of fold-out pages to your textbooks or used a really long sheet of poster paper, you wouldn't come close. On a diagram of the solar system to scale, with the Earth reduced to about the diameter of a pea, Jupiter would be over 300 meters away, and Pluto would be 2.5 kilometers distant and about the size of a bacterium, so you wouldn't be able to see it anyway. On the same scale, Proxima Centauri, our nearest star, would be 16,000 kilometers away. Even if you shrank down everything so that Jupiter was as small as the full stop at the end of the sentence and Pluto was no bigger than a molecule, Pluto would still be over 10 meters away. So the solar system is really quite enormous. By the time we reach Pluto, we have come so far that the sun, our dear, warm, skin tanning, life giving sun, has shrunk to the size of a pinhead. It is little more than a bright star. In such a lonely void, you can begin to understand how even the most significant objects, Pluto's moon, for example, have escaped attention. In this respect, Pluto has hardly been alone. Until the Voyager expeditions, Neptune was thought to have 2 moons. Voyager found 6 more. When I was a boy, the solar system was thought to contain 30 moons. The total now is at least 90, about a third of which have been found in just the last 10 years. The point to remember, of course, when considering the universe at large is that we don't actually know what is in our own solar system. Now, the other thing you will notice as we speed past Pluto is that we are speeding past Pluto. If you check your itinerary, you will see that this is a trip to the edge of our solar system, and I'm afraid we're not there yet. Pluto may be the last object marked on schoolroom charts, but the system doesn't end there. In fact, it isn't even close to ending there. We won't get to the solar system edge until we have passed through the Oort cloud, a vast celestial realm of drifting comets, and we won't reach the Oort cloud for another, I'm so sorry about this, 10,000 years. Far from marking the outer edge of the solar system, as those schoolroom maps so cavalierly imply, Pluto is barely 1/50,000th of the way. Of course, we have no prospect of such a journey. A trip of 386,000 kilometers to the moon still represents a very big undertaking for us. A manned mission to Mars, called for by the first President Bush in a moment of passing giddiness, was quietly dropped when someone worked out that it would cost $450 billion and probably result in the death of all the crew, their DNA torn to tatters by high-energy solar particles from which they could not be shielded. Based on what we know, based on what we know now, uh, and can reasonably imagine, there is absolutely no prospect that any human being will ever visit the edge of our own solar system, ever. It is just too far. As it is, even with the Hubble telescope, we can't see even into the Oort cloud, so we don't actually know that it is there. Its existence is probable but entirely hypothetical. But all that can be said with confidence about the Oort cloud is that it starts somewhere beyond Pluto and stretches some 2 light years out into the cosmos. The basic unit of measure in the solar system is the astronomical unit, or AU, representing the distance from the Sun to the Earth. Pluto is about 40 AUs from us. The heart of the Oort cloud about 50,000. In a word, it is remote. But let's pretend again that we have made it to the Oort cloud. The first thing you might notice is how very peaceful it is out here. We're a long way from anywhere now, so far from our own sun that it's not even the brightest star in the sky. It is a remarkable thought that distant tiny twinkle has enough gravity to hold all these comets in orbit. It's not a very strong bond, so the comets drift in a stately manner, moving at only about 220 miles an hour. From time to time, one of these lonely comets is nudged out of its normal orbit by some slight gravitational perturbation, a passing star, perhaps. Sometimes they are ejected into the emptiness of space, never to be seen again, but sometimes they fall into a long orbit around the Sun, about 3 or 4 of these a year, known as long period comets, pass through the inner solar system. Just occasionally, these stray visitors smack into something solid like Earth. That's why we have come out here now, because the comet we have come to see has just begun a long fall towards the center of the solar system. It is headed for, of all places, Manson, Iowa. It is going to take a long time to get there, 3 or 4 million years at least, so we'll leave it for now and return to it much later in the story. So that's your solar system, and what else is out there beyond the solar system? Well, nothing much and a great deal, depending on how you look at it. In the short term, it's nothing much. The most perfect vacuum ever created by humans is not as empty as the emptiness of interstellar space. And there is a great deal of this nothingness until you get to the next bit of something. Our nearest neighbor in the cosmos, Proxima Centauri, which is part of the three-star cluster known as Alpha Centauri, is 4.3 light years away, a sissy skip in galactic terms, but still 100 million times further than a trip to the moon. To reach it by spaceship would take at least 25,000 years, and even if you made the trip, you still wouldn't be anywhere except at a lonely clutch of stars in the middle of a vast nowhere. To reach the next landmark of consequence, Sirius, would involve another 4.6 light years of travel, and so it would go if you tried to star hop your way across the cosmos. Just reaching the center of our own galaxy would take far longer than we have existed as being. Space, let me repeat, is enormous. The average distance between stars out there is over 30 million kilometers. Even at speeds approaching those of light, these are fantastically challenging distances for any traveling individual. Of course, it is possible that alien beings travel billions of miles to amuse themselves by planting crop circles in Wiltshire or frightening the daylights out of some poor guy in a pickup truck on a lonely road in Arizona. They must have teenagers after all, but it does seem unlikely. Still, statistically, the probability that there are other thinking beings out there is good. Nobody knows how many stars there are in the Milky Way. Estimates range from 100 billion or so to perhaps 400 billions, and the Milky Way is just one of 140 billion or so other galaxies, many of them even larger than ours. In the 1960s, a professor at Cornell named Frank Drake Excited by such whopping numbers, worked out a famous equation designed to calculate the chances of advanced life existing in the cosmos based on a series of diminishing probabilities. Under Drake's equation, you divide the number of stars in a selected portion of the universe by the number of stars that are likely to have planetary systems. Divide that by the number of planetary systems that could theoretically support life. Divide that by the number on which life, having arisen, advances to a state of intelligence, and so on. At, it, at each such division, the number shrinks colossally, yet even with the most conservative inputs, the number of advanced civilizations just in the Milky Way always works out to be somewhere in the millions. What an interesting and exciting thought! We may be only one of millions of advanced civilizations. Unfortunately, space being spacious, the average distance between any two of these civilizations is reckoned to be at least 200 light years, which is a great deal more than merely saying it makes it sound. It means, for a start, that even if these beings know we are here and are somehow able to see us in their telescopes, they're watching light that left Earth 200 years ago. So they're not seeing you and me. They're watching the French Revolution and Thomas Jefferson and people in silk stockings and powdered wigs. People who don't know what an atom is or a gene and who make their electricity by rubbing a rod of amber with a piece of fur and think that's quite a trick. Any message we receive from these observers is likely to begin, "Dear Sire," and congratulate us on the handsomeness of our horses and our mastery of whale oil. 200 light years is a distance so far beyond us as to be, well, just beyond us. So even if we are not really alone, in all practical terms we are. Carl Sagan calculated the number of probable planets in the universe at as many as 10 billion trillion, a number vastly beyond imagining. But what is equally beyond imagining is the amount of space through which they are lightly scattered. If we were randomly inserted into the universe, Sagan wrote, the chances that you would be on or near a planet would be less than 1 in a billion trillion trillion. Worlds are precious, which is why perhaps it is good news that in February 1999 the International Astronomical Union ruled officially that Pluto is a planet. The universe is a big and lonely place. We can do with all the neighbors we can get.